Welcome once again. Let's continue our discussion on determining structures. In the previous videos, I have introduced to you the idea of long chain, longest chain, and then we looked at isomers, how to determine different isomers given a molecular formula, and then we talked a little bit about boiling point. We're going to further our extension. A lot of what you learn is very similar. However, we're not going to talk about boiling point for alkenes and alkynes because they slightly have different ways and it's not that straightforward. However, determining structures is sort of very similar. So let's start off by writing the general formulae for an alkene. Okay, here's the general formula, and as always, you do have to remember this. N corresponds to the number of carbon atoms. Okay, so let's get started by saying C5. If I have 5 carbons, then I'd have 10 hydrogens. Okay, so there's one way I could ask these questions by the end of this section on alkanes, alkenes, and alkynes is I could give you a formula and then ask you if it's an alkane, alkene, or alkyne. So all you got to do is put the number of carbons into a formula. If you can get back this using this, well, then it's an alkene. If you put the number of carbons, but you don't get this, but you get something else that corresponds to the formula of an alkane, then it's an alkane, and so on. So how do we draw structures? Well, as with your alkanes, you start with the longest chain. Now, there is only one thing that I had to add in terms of rules. Now, alkenes are characterized by double bonds. Okay, now both alkenes and alkynes are part of the unsaturated hydrocarbons. Okay, I've already made that very clear. Unsaturated means there's a double bond between carbon and carbon. Okay, it is not automatically unsaturated because the compound contains a double bond. No, the double bond must exist between carbon and carbon. Now that's for alkenes. Okay, alkynes, there must be a triple bond between carbon and carbon. Okay, that's what constitutes unsaturated. Just because there's a double bond in the compound, you will see later when we start incorporating oxygen into the pile. Okay, currently all of these involve only 2 elements, carbon and hydrogen. So with this in mind, double bond cannot ever be on the end. Okay, so the only place you can start it would be here. That's your straight longest chain. That's it. Okay, when you use this formula, by default there can only be one double bond in the entire molecule. Okay, let's redraw this again. The longest chain, that's 5 carbons. Now we can have the double bond here. We moved it 1 carbon more. Okay, now let's go ahead and actually complete the hydrogens for this. You look at 1 carbon at a time. This carbon currently has 3 bonds, so you can only have 1. You can put it at the top or bottom, it doesn't matter. This carbon again has 3 bonds, so only 1. This carbon has 2, so 1 above, 1 below, 1 above, 1 below, 1 above, 1 below. Okay, we moved here, so the double bond, this can have 1 above, 1 below. This carbon already has 3 bonds, so 1. This carbon has 3 bonds, so it's 1. This can have 1 above, 1 below, 1 above, 1 below. I'm going to start putting hydrogens here. Keep in mind, this is with this. Okay. Similarly, I'm going to change this up, just different so you can not get confused. Okay. Now you could move it one more, but that is same as doing this. So that's not going to work. So is this. So as far as the straight chains itself, the one key thing, remember I said there's one additional rule I want to add, is the double bond must be part of the chain. Let's say you are thinking like this, all right? Let's say, remember even when I started saying that, the double bond cannot be on the outside. It must always be part of the long chain, and it cannot be on the outside. So this is not possible, all right? And also say if this is your longest chain, okay, then the double bond must be in the chain. Whether it's written this way or straight, it cannot be sticking out, okay? This is also not possible. So if you have to continue drawing other structures, well, again, this time, let's just put 4, okay? And then we'll put the 5th carbon in the middle. Now you can move your double bond around. Now keep in mind, the double bond cannot go here, here, nor here. It cannot be sticking out, okay? If you think this is your long chain, then the double bond can only be inside, it cannot be outside. If you think this is your long chain, then again, it must be within the chain, not outside the chain. Think of it that way. So I can put it here, okay? Or I can redraw this in the same place, but this time I can put it here. These two are not the same, okay? These two are not the same. Now let's go fill it up with bonds. This can have 2, this can have 2. This already has met 1, 2, 3, 4. So this cannot have any more bonds here. This can have 1. This can have 2. This can have 1. This is full already. So this can have 2. This can have 3, and so is this. So let's go put hydrogen on all of them. Does that make sense why I'm taking my time to do this way? So it's definitely beneficial. Now I have done, I believe, 4 structures so far. And if you are adventurous, you can try to come up with maybe 1 or 2 more structure without violating any rules. The rule you cannot absolutely violate is carbon cannot have 5 bonds or 3 bonds, nor the double bond cannot be sticking outside. It must be part of the chain. You see, it's always sandwiched as part of the longest chain. So we've so far done what? I have done 1, 2, 3, and 4. What I'm going to do is, why don't you try to do this 1 step below, and then in the next video, or if you're adventurous, let's go 1 step above. Try to draw as many as you can. If your understanding of what I have explained in this is minimal, then you may not even be able to come up with 1 or 2. But if you understood what I have explained here, this is simple. All right, now this is expanded structure, and you can also write concise structure. I'm just going to write it for one of them. Say for this one, it's CH3, CH2, CH2, CH, double bond, CH2. You can do the same. But I want you to really focus on, see if you can come up with some isomers, including the double bond, because these are all part of this formula. If you put 4, you get H8. You put 6, you get 12. So try to come up with at least 1 or 2 to get started so that you can ask questions. And I'm going to make 1 more video where I might probably write a couple of structures for this one. I still want you to try to battle and figure this out. All right, stay tuned.